Alright, we're going to draw some ray diagrams here. Words are hard. So we got four different mirror and lens types. We got the concave mirror, convex lens, or converging lens, and concave or diverging lens. Alright, so start out with the rules. Okay, for mirrors, there are two rules for drawing ray diagrams. One, through the focus, okay, reflect, parallel. Second rule is through, parallel, reflects, through focus. Okay. For lenses, similar. Okay. First is parallel goes through focus and to the center, continues straight. Alright, so let's look at our first one, our concave mirror. So what I mean by one is through the focus. That means from any point on this image, if I were to take that spot and draw through the focus, it's going to reflect back to that point. I'm going to shift this slightly, make it a little easier. Okay. So we have a ray light reflecting off the tip of the image, goes through the focus, and it hits the mirror. Now, it's then going to reflect off parallel to the central axis. And that's one path light can take from the tip of the image. Second one is parallel reflects through the focus. So if we're to go parallel, then reflect through the focus just like that, and we have two beams of light. Now, the reason we have to do it twice is because our eyes detect 3D images by seeing slightly different perspectives. So for an object to be where it is, no matter where our eyes are, it has to, the light from that spot has to converge, or has to all be coming from the same point. Okay, so we want the image to be at a spot where no matter where our eyes are, here or here, it's going to look like it came from the same spot, and that's where they intersect, or right here. And so in this case, we get an image that is virtually identical but upside down. Alright? Now moving on to the convex mirror. Okay, same rules, except now that the object's on the other side. Now, so we come in, parallel. Okay, I'm doing number 2 here. And now, theoretically, we want to go through the focal length. Parallel reflects through focal length. Except that obviously the light's not going to go through the mirror. So instead it's going to reflect off on an axis that goes through the focal length. So reflect off upwards. Okay? Second one is through the focal length, it's going to reflect off parallel. Okay? Now you'll notice, these two rays will never intersect. But we can extrapolate. We want to know where our eyes are going to think that these two things originated from. Where did they both come from? Because they're both going to be seeing the same image. So if we actually backtrack, remember our eyes are going to be tricked into thinking that ray was continuing forever. When we backtrack, okay, we're going to see that it's going to appear to us they both originated behind the mirror. Okay, this is typically how mirrors work. Mirrors you see in like car rearview mirrors. When they say image is closer than it appears, that's the kind of thing that we're talking about when we see an object behind a mirror, or image is smaller than they appear. Okay? We're seeing a small object that looks like it's behind the mirror. Now, we figured out that we can interpret that as a reflection. But in reality, our eyes are still tricked into thinking that the image is there. Alright, now let's go on to our lenses. Okay, parallel goes through the focal point. Parallel in, reach the middle of the lens. You always want to draw through the middle of the lens, otherwise you get some weird little errors in it. It's not a huge deal, but if you're going to do it, you might as well do it right. And we draw through the focal length. I need to keep going on this one. Okay? Second one is through the center. Continue straight. So through the center of the lens. If we go through the center of the lens, it should continue straight away. Like that. And we have our image inverted on the other side. Finally, we have the diverging lens. In this case, the focal point is on the same side as the image. That shouldn't affect what we do. We're still going to go. We're still going to go parallel. And then it's going to diverge and spread out a bit. Meanwhile, we're also going to go through the focal point. Through the center, and it's going to continue straight. Okay? Now, in neither of those cases, those two again are also not going to converge. So we have to backtrack. When we backtrack, this one obviously is going to be straight, but this one, if we backtrack through the focal point, we get an image right there. And that is RayDiagrams.